occupational category as a factor, if you want. And then we have institutions and there's households. There we have agricultural employees household, farm size 1, farm size 2, farm size 3, rural lower, rural middle, rural higher, urban lower, urban middle, urban higher. And then we have companies. And then we have the input-output system, beginning with the agricultural sector, the food crop part of the agricultural sector. So we have, all in all, 74 endogenous accounts in this particular way of looking at this SAM. And then we have exogenous accounts. We have government, we have capital accounts, net indirect taxes, and rest of the world. And sums, as I said, must add up. Now, here we are actually doing some modeling too, but I will come back to that. And if we now focus on gender-aware SAM, a good SAM is simply one that is consistent and disaggregated in the appropriate way. But here we must have an appropriate classification scheme with respect to gender. It can be done in at least 2 ways, and perhaps more. First is to look at the factors. There are male workers and female workers. One thing that we did when we advised the Indonesian Central Bureau of Statistics in preparation of their SAM is to collect information through their labor force survey on both male and female workers. So in the largest Indonesian SAM, you have really a lot of good information on gender differentiation of workers, where they work, how much they get paid, and so on and so forth. So that's one aspect. On the factor side, you can disaggregate according to gender. The second would be on the household side. Which households are female-headed households, or how many women are there in the different kinds of households? What would be the best kind of classification in both rural and urban areas of households that would capture gender as an important dimension? And then, of course, you hope that the coverage would be relatively complete, at least. And you have to check for macro consistency, that is overall how consistent things are between different accounts, and how it corresponds to the national income accounting data. That's because that's an alternative source. And then micro consistency. You have all these surveys. I mentioned labor force survey. Another important survey would be household expenditure survey. In a lot of countries, now there are standardized surveys of this type carried out at regular intervals. So you have a lot of good data, but you need to check the consistency of this data. And then you are using data from different surveys. So you have to compare and check for consistency between these surveys, different surveys. So it's a little more complicated than it seems. And then for welfare analysis, the role of household classification scheme is really extremely important. I can't really overemphasize how important the role of household classification scheme is. In Indonesian case, for example, we were interested in especially the rural households, and therefore we have more rural households than urban households. But if you're interested in, say, social and economic stratification in the US today, then you'd have to put much more emphasis on urban households and the stratification among the various urban households. If you're interested in rural poverty, of course, you'll have to perhaps even classify a SAM for US regionally. The Delta region in the Mississippi and the rural folks there, many of whom are poor, probably will need to be specified as a special region and connected to the rest of the US SAM. So you can see that it's important to know what it is that you're going to use the SAM for. Okay, the early examples, Indonesia is one, Bangladesh is another one. I mentioned household and labor force surveys. On the left-hand side on the slide, the acronym in Bahasa Indonesia is there, SUSENAS, that's for household survey, and then Sakernas, which is labor force. The word for labor force in Bahasa Indonesia is tenaga kerja. Kerja actually comes from Sanskrit, which means work. And tenaga is a Malay word, which means power. So literally, it means power of work. But both these are very good surveys in Indonesia. They did a great job in doing these surveys. The input-output table, the productions part, that comes from a bilateral Japanese-Indonesian project. And the Japanese really did transfer the technology of doing this, the knowledge and skills quite well. So the Central Bureau of Statistics in Indonesia keeps doing very good work on input-output side as well. And now they are producing regular kind of data. Now, what do we do with these good SAMs? Well, we can do different kinds of models: fixed price multiplier models, flex price models, and mixed mode models. Flex price models are CG models to be discussed elsewhere. But if you look at page 70, the next page, after the SAM classification, you see that it's a table of fixed price multipliers giving effects of selected dualistic production activities on household income distribution. Again, we have listed on the left-hand side those accounts that are households, and then we have these production activities, and each number actually gives you the answer to the question: by how much would income of a particular household increase if you had, say, $1, or in Indonesian currency, 1 rupiah increase in expenditures of demand of those goods. So this is a demand-driven model, and you can get specific numbers. And when you add up all these numbers, of course, you get a multiplier that is greater than 1, in this case greater than 2, most cases, and sometimes close to 3. Okay, so it is easy to see how to calculate multipliers. If you derive this average propensities matrix, which is something that you derive by dividing each cell with row total or column total. The corresponding row and column totals should be the same. And if you go back to the earlier part on page 24, the second page of the handout, you will see that we have some very small numbers here. And these are those average propensities. You get this average propensities by dividing the corresponding cell with the row total or the column totals sum. So these are small average propensities. And in the Keynesian model, we know that multiplier equals 1 over marginal propensity to save in a closed economy. In an open economy, it would be a little different, of course. In a matrix, which is huge, you have to introduce a symbol. The average propensity is be A. And marginal propensity and average propensity are related. You get marginal propensity by taking the income elasticity. And income elasticity, let's call this eta. Income elasticity is ratio of marginal and average expenditure propensity. Right? This is an economic relation that is always true. If that is the case, then this average propensity multiplied by the income elasticity should give you the marginal expenditure propensity. So this should be A times eta. And let's call that matrix C matrix. Once you have that, then in analogy with Leontief input-output inverse, multiplier is simply going to be identity matrix minus this C matrix in inverse. Here you can see that this is also an inverse, but this is a simple inverse in ordinary algebra. Here it's a more complicated inverse, but the idea is the same. It's an inverse in matrix algebra. Okay? Psi minus C inverse. And those multipliers that you saw really came from this matrix, this huge inverted matrix. But one can go even further and try to disaggregate the influences, because we know the total multiplier, great, but we might also want to know what are the channels through which this multiplier effect is obtained. If we did know more than just this, then we'd be still stuck in Principles of Economics 101, right, or 102, macroeconomics. To go further, we need to disaggregate. Then we can actually do that by redefining the multiplier matrix. So if you go to page 74, which is after that multiplier submatrix on page 70, page 74 on your handout, the middle of the page lists an item called global influence. It's item number 3. So, and here we explain that global influence, in contrast with direct and total influences, does not refer to topology, namely the specific paths followed in the transmission of influence. Now, I should pause here and define direct and total influences. Direct influence is when you go from, say, one node to another in the matrix. And I will show you soon through diagrams what I mean. Total influence is when you have also a kind of looping around, and you have several different paths, and you have to add them up. So the key to what we are doing now is to realize that there are many different paths by which any kind of economic influence travels in the economy. The economy really is a complex system. And Quenet, the physician, was not too far wrong in drawing the analogy of circulation of blood, which is very complicated, definitely. So we can use the similar kind of path and circulation analogy. So the next statement to read here is, the global influence is captured by the reduced form of the SAM model derived previously. And this is dyn is differential. If you did it in discrete terms, it would be just that del, that triangular del yn. Again, this is the inverse of that matrix, that is the multiplier matrix, and then the change in the exogenous variable. X is the exogenous variable. So you can write down for short mc times dx. And then you can try to break down this MC matrix to get all the paths. And in the next page, page 75, we have a diagram that shows the network of elementary paths and adjacent circuits linking poles I and J. So I is the origin of some disturbance. Let's say you injected some money in the rice sector in this agricultural economy. Then, and J could be the income of small farmers. But in between, there are many different circuits and paths. So we are showing here 3 main paths, but on one of them, there is also looping around. The first one, the top one, going from X to Y, and then coming back to X again, and going from X to Y, and then coming back to X through Z. So it's very, very complicated when you try to look at it. And of course, we could never draw all these diagrams by ourselves. Even with a computer, it would require a long time. So we usually try to cut it off after some point. When the influence gets, say, attenuated to the, say, 0.005 level, we say we don't need any more. And we can also specify the number of nodes, the points in the path that should be included. And here we have included really 2 or 3 at most. And we have shown on page 83, which is the last page of this handout, 2 diagrams. Here you have, and it's very interesting because you have 2 types of sugar in Indonesia. One is the brown sugar, which we now know is more healthy. It's better to have brown sugar than white sugar if you're going to have sugar at all. And brown sugar is also produced by using a much more labor-intensive technology. And it is produced locally in the village. Refined sugar is sugar that is produced in larger mills. And people for a long time thought that, as the name refined sugar indicates, that that was a better product, a more modern product, something that educated people in the cities or people who lived in Europe and America consumed. So although the traditional mode of consumption was brown sugar, and that was, we now know, a healthier practice, the modernization process and industrialization process led people to switch from brown sugar to refined sugar, especially the upper income, better educated people, ironically. The beauty of the SAM approach is that you can trace those things through as well, through households, consumption of households. But I have done here just for income. So you see brown sugar travels through many different routes to small farm households. And one of them is through unincorporated rural capital. Another is through land. And the rest are through various kinds of labor categories. So this is a marvelous way of capturing the way income travels in a society. And other things also travel in society. And we can do the same thing for refined sugar. And it's not just qualitative, tracing the paths, but also quantitative. You can show how much influence is traveling through which path. And you can isolate and disaggregate the various points of this. Okay, so this is the fixed price modeling, fixed price multiplier modeling. Let me stop and see if you have any questions about this one. Okay, so it's fixed in your mind from now on. Okay, now let's turn to India. I've done some work on India also, and I have created a CG model for India. And I've done some work on fixed price setting with colleagues in India. In India, the history is more recent than in Indonesia. They had fairly ad hoc SAMs before the 1990s. There was one for some kind of energy project. That's the item number 2, this REGEMI SAM, REGEMI SAM. But the specification is very, very poor. The National Council for Applied Economic Research, which is a quasi-governmental research organization in New Delhi, created a first SAM in 1994-95. And since then, it has improved on those things, and that's what I have called other NCAER SAMs. The 1994-95 SAM had both strengths and weaknesses. On the strength side, it used both input-output and survey data. And that was a very good thing. The Indian Central Statistical Office has always been much better equipped than most developing countries. In fact, Indian statistical offices were set up even before independence, but after independence, they had some really brilliant and competent people who managed these databases and extended them in many, many useful directions. Also, the consistency checks that I mentioned before are much more detailed in this SAM than the former ad hoc SAMs. But there are some weaknesses as well. The household specification is poor, and labor force specification is also poor. And I found when I was looking at it carefully that there was quite a bit of lack of documentation of raw data. Maybe it existed once, but people didn't keep track of it and lost it. In Indonesia, I was able to trace things down in most cases and found the original sources and used them. Their more recent SAM, which is the one that I used in my modeling, has much better documentation, and it also reports on rural-urban gender disparities, but still needs to be more gender-focused. One of my fond wishes is that somebody would ask me how to do this right, and then I would tell them, and then they would let me work with them to make sure that we get it right. We also have regional SAMs. In Indonesia, they have a regional SAM for West Java, one for East Java. In India, they are talking about doing some village SAMs, but I don't know if they have done it. In Mexico, some people did village SAMs, and I think that was very good pioneering work. But we have a number of regional SAMs. The best one is in Africa, South Africa. South Africans started doing their SAM in the 80s, and then after the end of apartheid, they became much more interested in recording regional disparities among the different racial ethnic groups. And therefore, they have very detailed provincial social accounting matrices coming out of Pretoria. It's really a very good source of data for those who might want to work on Africa. So before I go to the nonlinear part, let me draw a few conclusions of this linear part. So we can follow the Indonesian model, but we need to focus, as they did, on some very specific set of problems, and emphasize comprehensive household and labor force surveys. Informal sectors are very important to look at, along with gender awareness. Marzia Fontana, who is originally from Italy, did some work with some collaborators in Bangladesh, and they came up with very good, decent kind of gender-aware SAM. And on the factor side, capital is something that we also need to look at more closely, and we need to include financial flows, something that I did with the Indonesia SAM that I then applied to do that model for the Asian financial crisis. So all these things can be, and some have been done, and there are more things to come. I think there's a quote from Tinbergen, but we'll come to that after we undo the nonlinear part. For the nonlinear part, we can now go to the second book. And this is the book that I did by myself. It's called Interpreting East Asian Growth and Innovation. I realized in doing a number of studies on technology and well-being of people that you really need nonlinear models to do this. But at the same time, I did not want to lose the focus on well-being of the people that you can have in a detailed way in a social accounting matrix. So what to do? Well, I tell you what I did on page 42. And let me just read you one particular part of it. So we are looking at things in the context of an innovation system here.